Today we learn all about cameras in 3D software, and I'm not gonna talk about any specific program. I will show you which options cameras have and how you can control them in 3D. So this is universal lesson. Cameras in 3D simulate real cameras, so if you know the basics of photography, it will be easy for you. But in 3D you are not limited to a physical correct simulation of a real camera. You can go far beyond correct to achieve desired results, or use settings for which you would need thousands of dollars worth of equipment. So let's understand how a real camera works. It's quite simple. The camera collects all the light it sees in front of it through its lens, and captures it with a highly sensitive sensor when the shutter opens. All this controlled by 4 parameters: focal length, aperture, ISO, and shutter speed. So let's look into them. Focal length is the distance between the camera's lens and the image sensor. It determines the angle of view, or how much of a scene is captured by the lens. Also, the greater the value, the more the perspective is compressed. And if you want to simulate human eyes, use focal length of 50 mm. Aperture determines size of the opening of the lens through which light passes to the sensor. It measured in f-stops. The smaller this value, the more open the aperture is, and accordingly more light gets to the sensor and the image gets brighter. ISO determines the amount of energy that used by camera sensor. It measured in values that multiplies 100. The higher the value, the brighter the image, but also there's more noise. And shutter speed. This is the amount of time that the camera's shutter remains open, measured in seconds or fractions of a second. And the less time the shutter is open, the darker the image appears. Now we only talked about how these parameters affect brightness, but they also affect 2 important visual aspects of images: depth of field and motion blur. Depth of field allows you to make focused objects sharp and the rest of image blurry. And 2 parameters affect this effect: the focal length and the aperture. The larger the focal length and the smaller the f-stop, the thinner the focus area will be. Additionally, distance from the object affects this effect. The closer it is, the thinner the focus area. This effect is frequently used to show depth in an image or to highlight the main element. And motion blur, which allows you to show the motion in the image. The longer the shutter is open, the more pronounced this effect becomes. Now that we covered how real camera work, let's talk about 3D. There you can use same parameters, but you have more control over everything. For example, you can turn off motion blur and depth of field, or not allow parameters to affect the exposure. Or you can go beyond physical correct parameters, or have full control of the noise in the image. So we covered the main parameters. Now let's look at what else we can set up. Camera type. There are 3 main camera types: perspective, orthographic, and panoramic. Perspective cameras simulate how we see the world, where distant objects appear smaller, creating a sense of perspective. Orthographic cameras, on the other hand, don't take distance into account and display objects at the same size regardless of the distance from camera. They are commonly used in modeling and design to easily work with scale. For example, all the view cameras in 3D programs are orthographic. And panoramic cameras. They are a type of perspective camera that allows you to capture a 360-degree scene. They are often used to demonstrate scenes or create HDRIs. In 3D we also have additional control over depth of field. We can set a focus point and add a bokeh effect. This effect occurs when light sources form circular shapes in blurry areas of the image. The roundness of the shapes is controlled by the blades parameter. The more blades, the smoother the circle. Clipping. If you ever experience that the part of your image seems to be cut off, it's because of this setting. It specifies the range in which camera will show and render the image. This parameter is often used for optimization, or to hide unnecessary scene elements. Zoom. Unlike focal length, this parameter allows you to simulate the effect of zooming in without affecting the depth of field or perspective. It's also called digital zoom, and it's identical to how you zoom in on an image in 2D viewers, with the difference being that you don't lose quality. White balance allows you to mix blue or orange color to the image taken by the camera. It's often used for stylization. Sensor size. This parameter controls the size of a camera sensor, and it's another way to control field of view. It's often used when you need to match a virtual camera to a real one, such as for motion tracking. Background image. The camera has the ability to attach an image to it, which will be displayed behind all scene elements. This is often used to attach references or add a background. Vignetting. This effect adds darkening to the edges of the image, but it's often added in post-processing and not in camera settings. Distortion. Camera lenses slightly distort the objects you capture by shrinking or stretching them. If you need to simulate this effect, use this option, or you can add it in post-processing. Tilt shift. These parameters allow you to shift the camera view horizontally or vertically without changing the camera position or rotation. These are often used to create a more natural and visually pleasing composition by eliminating distortions caused by a small field of view. So we got the parameters figured out. In the program that you work, the parameters may have more control, or they will be located not in the camera options but in rendering settings. You don't need all of them for each image, but understanding them will give you much better control over the final result of your rendering. And lastly, let's break down not parameters but an important part of interaction with the camera. And that's how the camera movements are called. Knowing them is important for interacting with your colleagues, and just being able to explain what you're going to do with cameras. So here are the movements. Dolly, moving the camera towards or away from the subject. Track, moving the camera from side to side. Pedestal, rising or lowering the camera. Pan, rotating the camera horizontally on its axis. Tilt, rotating the camera vertically on its axis. And roll, rotating the camera along its longitudinal axis. And this will be it. Thanks for watching, hit like and subscribe, and I wish you perfect camera control.